Namaskar to all. This is one more video lecture in the series of lectures for water treatment. And today, in this video lecture, we are going to discuss about the ion exchange method of softening of water, and it is also called as demineralization of water, because in this method complete removal of all kind of minerals takes place literally, and therefore it is also called as demineralization of water. In earlier lecture, uh, we saw the zeolite process. It was a cation exchange process where only cations in water, those are the calcium and magnesium, are only removed. Thus, hardness is removed from water in zeolite process, but at the same time, the water is left with anions that cannot be removed from water. Thus, here we will see both cations as well as anions are removed, and thus it is complete demineralization of water. And the ion exchange method, it uses the cation exchanger as well as anion exchangers. So it uses resins which are mostly synthetic of nature. So synthetic resins are used, and these synthetic resins are, one is which can replace the cation, it is called as cation exchanger, and the another one which is anion exchanger. Thus two type of resins are packed in two different columns, and the two different columns works one by one, so that uh, the complete removal of anions takes place. We will see uh, what exactly are those resins, and the resins are having organic backbone. They are uh, polymers of organic nature, and they are prepared recently. It is a recent development. uh, National Chemical Laboratory prepared some resins few years ago, and those were then prepared by mm, one of some of the manufacturers. So they are mostly of melamine base uh, backbone or polystyrene base backbone. Basically, they are simple polymers with aromatic backbone, and the benzene rings are substituted with some functional groups which acts as the site of exchanges. So some labile ions are there, hold up, which when comes in contact with water as mobile phase, uh, it traps the ions from water like calcium and magnesium, and gives in return the another type of ions which will not impart the hardness to water. Thus, hardness from water is removed. So, if we see the cation exchange resins are mostly having some acidic functional groups. Like you can see some groups like SO3H, sulfonic acid group, are there. So, such resin can be drawn, though studying the structure of the resin is not the objective of this syllabus, but still we can draw some resin, just a schematic. So if the resin is of sulfonic acid group, then such groups can be there, and these groups when reacts with say calcium ion from water, then these groups will held up, it will trap the calcium ion and rest of the part will be as it is, and it will give two H positive ions to water. So this is the role of cation exchange resin. Here the strongly acidic group SO3H group is there. So the resin may have a strongly acidic group like SO3H. So this is a one type of resin. We list down those down. Strongly acidic resin have SO3H group. Then some moderately strong cationic resin are having such groups. Then some weakly acidic groups develops or derives the weakly acidic cation exchangers. Weakly acidic cation exchangers are of such nature. So a benzoic acid or phenolic group, all of us know it is a weakly acidic group. Such groups are there. The basic resins, next type, are also strongly basic and weakly basic. Mostly they are of quaternary ammonium salt type in nature. R3 is mostly CH3 C2H4 type of group, CH2 or C2H5, like that. So these are some of the groups which are there in cation exchange resins and in anion exchange resins. Now how they work, the cation exchange resins, when you treat those or when you treat the water with cation exchange resin, then the calcium and magnesium as cation is trapped by the cation exchange resin. And so for example, I will write the calcium bicarbonate as representative of the hardness from water, and I write H2R. This is the cation exchange resin. You have seen sulfonic acid group or COH. So for to write in general, I have written it as R2H. This gives CAR plus twice H2O and twice CO2. And thus the resin is now exhausted. That part of resin which took up the calcium is now exhausted. Similar reaction can be written for magnesium. Which reacts with the resin to give MgR, the exhausted resin, and similar reaction, similar products. It should be CO2 here, like that. So this is the role of cation exchange resin. If we consider the calcium chloride as calcium permanent hardness in water, that also gives the same result. Here twice NaCl is formed, If we consider calcium sulfate, then sodium sulfate is formed, and all these goes in water. These species goes in water. Thus, cations are held up. You can write similar reactions for magnesium as well. And the water is having this part. Now, when such resin, such water is passed into the next column, say here, sorry, when we have taken the hydrogen cycle, then it should be HCl. It should not be sodium. Here it should be sulfuric acid. So if the resin is running on hydrogen cycle, then this should be acid. Thus the water is having acidic species, and when such water is allowed to react with the anion exchange resin, I will represent anion exchange resin as ROH by 2 plus say H2SO4 or twice HCl. This is the water that came out from the cation exchange resin. In such case, it will give up the OH and take the SO4, or here RCl2 plus H2 and OH will give you H2O. Thus what is left in the water is H2O only. Thus complete minerals are removed. In first case it was cation which was removed, and in next step it is the anion which is removed. Thus the water that is poured in gets completely free of the minerals. So these are the reactions that take place in the cation exchange resin and the anion exchange resin. In doing so, over the course of running such cycles, the resin gets exhausted. This CAR is a exhausted resin. Similarly, the anion exchange resin which is exhausted is RSO4 or RCl2. We can regenerate the resins by using chemicals, and cation exchange resin is regenerated using acid. Acid is used for regeneration of cation exchange resin. We will see how it takes place. Say we will take a cation exchange resin which is exhausted. RCA is the resin. It is when treated with acid, it gives RH2 and calcium sulfate. Thus the resin is regenerated. It is ready for use. If HCl is added, then it will give RH2 plus calcium chloride all these calcium sulfate and calcium chloride is part of washing. It goes to sink. It goes to sink. And similarly, we can see that the anion exchange resin which is exhausted, that is having RSO4 being the exhausted resin. When you treat such resin with alkali NaOH, then ROH by 2 is formed, plus you will see that sodium sulfate is formed. If it is exhausted and having such form, then it will give chloride salt in washing. You will see NaCl formed as product. Again here, both of these two salts becomes part of sink. It is waste, and these two are the regenerated resin. Thus, anion exchange resin can be regenerated using alkali. And both the resins are ready to be reused for softening next water. So this is all about the cation exchange and anion exchange resins. Now here we can see the schematic diagram of a ion exchange resin plant. You can see that the cation exchange resin is first employed. Always it is so. First cation exchange resin is attached. So the water is passed through cation exchange resin first, and then the water is passed through anion exchange resin. So raw water is fed in to cation exchange resin, filters etc. all other parts are there, and then exact cation exchange resin is there. First the water is passed through filter to remove the turbidity and all other things, and then it is allowed to react with cation exchange resin. Water which reacts with cation exchange resin is then passed on to next resin, that is anion exchange resin. Obviously pumping facility etc. is there. I have chosen the simplest diagram for explanation. So otherwise pump etc. is there. The water is pumped in to next resin, and it comes out through anion exchange resin which is completely deionized. Both the ions are exchanged and only H2O is given to water. Thus deionized water comes out. When both of the resins are exhausted, in such case raw water feed is stopped, and a side tank you can see is having acid for regeneration of cation exchange resin and alkali for regeneration of anion exchange resin. Now this comes into action. With a small pump, the acid from regeneration tank is pumped in so that it comes in contact with cation exchange resin, and the cation exchange resin is washed. Somewhere here it should be sink, side arm is there. To sink all the washing is passed, and then similarly alkali is added to anion exchange resin, where it goes in and it washes all the anion exchangers, and from the side arm, whatever side product that comes, that is passed on to sink. So like that, the demineralizer plant is regenerated and reactivated for use. So this is all about the ion exchange resin. In the picture you can see the actual size ion exchange resin unit attached, set up in industry. You can see the height and see the dimension at which it works. This is all about the ion exchange method of regeneration, the demineralization of water. Now we will see that the outcome of ion, ion exchange unit is such that it forms, it gives out water with almost 3 ppm hardness. So this way, the outcome of this particular water is best in all the processes. But this process is costly because regeneration requires the acid and alkali to regenerate. Secondly, resins are costly material. The entire setup attached, pumps and all that, is all very sophisticated machinery, and therefore the cost of softening uh, is high. In fact, these are not the advantages, these are the limitations. So talking it as advantages also does not make sense. But these are the some of the features which we are discussing. The quality of water is best, and such water is used in high pressure boilers. So all the high pressure boilers of power plant need water with least hardness, and therefore such boilers require water to be purified from demineralization plant. Further, turbidity of water can adversely affect the plant. The clogging of resin takes place, and that will damage the resin. In fact, the system should be such that resin should not be damaged, and therefore people usually take care that the resin remains good and it lasts long, because it is the costly unit of the entire plant. So these are some of the features of ion exchange plant. Further thing is that some other features are such that we need to take into account that this water is used in high pressure boiler, then pharmaceutical industry uses demineralized water. because API and all other formulations, etc., uh, do not afford to have hard water. Cosmetics industry uses such water passed through demineralizer unit. Fine chemicals is one of the sector where this is used. Food and beverages, cold drinks, soft drinks, juices, jams, chocolate confectionery, all such units uh, uses demineralized water. In practice, the industry first treats the water to be used for their purpose through lime soda process and removes majority of the hardness, and then they choose either zeolite process or ion exchange process depending on their further use. Uh, Hardly any industry which uses large quantity of water uses zeolite or ion exchange unit directly, because it is not affordable. That will put the load on a unit, and the cost involved in softening will be too high. Therefore, the industry chooses lime and soda treatment mostly to remove majority of the hardness, and then pass on such water to the demineralizer plant. If the source of water is having very less hardness, then the industry may directly employ a demineralizer plant. But otherwise, if the hardness is significant, industry choose to use lime and soda process uh, primarily, and then uh, in the last stage they use such sophisticated and costly process. Ultimately, demineralization is the finest process of all the processes that we have seen. The output water is of finest quality and having least of the hardness, only 3 ppm hardness, and therefore this is the best treatment for softening water. So we will stop here. Thank you. Keep watching.